For the function defined here, find f of 0, f of 1, and f of 2 using the graph below. So we have the definition of our function, which is f of x equals x plus 1 if x is less than or equal to 1, and negative 1 where x is greater than 1. And we want to evaluate this function for 3 separate points. Now, we can absolutely just use the definition itself. That's no problem whatsoever. But one thing to keep in mind about a graph is a collection of all the x and y pairs that go together for values of your function. So I've already got all the x values and all the y values just by being able to read points on this graph. So I don't actually have to do any of the arithmetic. So if I want to know what f of 0 is, for instance, so I'll say this is a, and I'll do that in green. All right, so f of 0, I find x equals 0 and see where that point is on the y. And that's at 0, 1. So that means 1 is my answer. And if you'll notice, if you went to the function, all right, well, when x is less than or equal to 1, which 0 is, you use the first function. 0 plus 1 is 1. Same answer. A little bit easier just reading it from the graph, however. All right, let's try the next one. I'll do it in orange. F of 1. So, I've already used that point, but that's okay. So f of 1. Now, I have a choice. I can either go here up to this point or here down to this point. And I will use this one because that's where the closed circle is. That's where the function is defined. This is undefined right here. It doesn't exist at that point. It only defines where you have a solid circle or a straight line, curved line, through the graph. So this is at the point 1, 2, so f of 1 is 2. And lastly, let's look at f of 2. So f of 2, I find where x is 2, and then where that is on the y is here. So this would be at 2, negative 1, so the output value is negative 1. And you could certainly have used the definition of the function, but it's not really necessary.